Good morning students, welcome to physics class. In the previous lectures we have introduced basic dimensional formulas. I hope by now you have learned all the dimension formulas. Now, as we have introduced first application of dimensional analysis to convert a physical quantity from one system of unit to another. Now, today we have to do another application on its basis, that is to check the dimensional correctness of a physical relation. See, to check the dimensional correctness of physical relation, here we will apply principle of homogeneity. According to that, dimension formula of left hand side and right hand side, that means dimensional formulas of a physical relation on left hand side and right hand side must be identical, must be same. Only then the equation, the relation will be dimensionally correct. Now, to understand it, let me are taking few numericals. Numerical 1, check the correctness of the relation nu equal to 1 by 2L under root of T upon M, where nu is the frequency, L is the length and T is the tension. Mass, M is mass per unit length of the string. You have to check the correctness of this relation. So first of all, what you have to do? Now, as the relation is nu equal to 1 by 2L under root of T upon M. Within this relation, as this quantity, it is frequency. So you will consider left hand side. Now, dimension formula of frequency is T minus 1. As it is reciprocal of time period, so dimension formula will be T minus 1. Now, in the right hand side, you will put the dimension formula of length, tension, mass per unit length, and to find whether it is equal to that of left hand side or not. So, in the right hand side, the equation is 1 by 2L under root of T upon M. So, dimension formula of this term 1 by 2. This is dimensionless, no constant has any dimension formula. L, that is having formula L, under root of tension. Tension is a force. Force is having dimension formula MLT minus 2. And in the denominator, mass per unit length. Don't get confused with the term M. Here it is clearly mentioned in the statement that M represents mass per unit length. So now, here in the square root, first of all, M will be cancelled as M raised to the power 1 minus 1. L raised to the power 1 plus 1, T raised to the power minus 2. So here it will be in the under root M raised to the power 0, it means 1, L to T minus 2. So it will be 1 by L. Outside the square root, it will be LT minus 1. So now L will be cancelled out. What you will get? T minus 1. So you can see this dimensional formula on the right hand side is identical to that on the left hand side. So what you conclude? That left hand side is equal to right hand side and hence the relation is dimensionally correct. So by this way you have to check the correctness of any of the physical relation. Now next numerical is to check the correctness of the relation SNF equal to u plus a by 2 2n minus 1, where u is the initial velocity, a is the acceleration and SNF is the distance travelled by the body in nth second. As this is a new relation, you will derive this relation in the next unit, kinematics, but here as we have to just check the correctness of this relation dimensionally, so we will use it here. Main point, you have to just careful about understanding the statement distance travelled in nth second. Here T refer to time, U is speed, velocity and A is acceleration. So you have to check the correctness of this physical relation. Now in this statement SNF, distance travelled in nth second, that means distance per second. So when you will take dimension formula on left hand side, so dimension formula of SNF, you can take it as distance per unit time, nth, 1 second. So it will be LT minus 1. This is the main point. You have to just pay attention. That's why I have marked star here. Now right hand side. Right hand side is u plus a by 2, 2n minus 1. So here when you will substitute dimension formula, what you will get? U. That is u will, as the term is u plus a by 2, 2n minus 1. So u is initial velocity having formula lt minus 1. Whereas a is acceleration lt minus 2. 2 is dimensionless. It is not having any dimension formula being constant. 2 multiplied by n. That is again 2 is constant, n is the time, and 1 again is a constant. See, this term is representing velocity. So when you will solve it, this will also represent the having the same dimension formula. LT minus 2 into T, this will, you will see LT minus 1 plus LT minus 1. So just remember, just recall the points as we have done in principle of homogeneity. As according to that, dimension formula of every term on the left side and the right side must be equal. Here it is the sum of two terms. So these terms can only be added when they have the same dimensional formula. So what will be the result? Dimension formula, that will be LT minus 1, being numerical value is having no dimension formula. So what you are getting, that left hand side and right hand side having the same dimension formula. So that's why you will consider it to be dimensionally correct. So by this way you can do any number of numericals. The method will remain to be the same. Main point which you have to consider, that you must learn dimension formula of each quantity. So now coming to the next numerical, check the correctness of the relation H equal to 2 sigma cos theta upon r square dg, where as the terms must be specified, without it you cannot solve it. So where h is the height, sigma is the symbol for surface tension. Whatever symbol has been specified in the statement, use only that one. Theta is angle of contact. This is a term that will be introduced later on when you will study the concept in properties of matter. So you have to take the statement as such for correctness of relation. R is the radius, B is density, and G is acceleration due to gravity. So beta, this relation is new relation. We have to check whether this is dimensionally correct or not with the new terms introduced here: angle of contact, surface tension, density and all. So just you have to not to understand the meaning of this term, what is angle of contact here, what is surface tension here. Simply you have to substitute the dimension formula of each term. The relation may not be correct also. That's why you have to put the values carefully. So see the statement, H is equal to 2 sigma cos theta upon r square dg. First of all, you will consider left hand side. Left hand side, dimension formula of H. H is the height, is L itself. Now in the right hand side, what are the terms here? Surface tension, theta, r, dg. So you must know dimension formula of each term on the right hand side. We can write the dimension formula each term separately, or we can put them in the values. So dimension formula of the relation 2 sigma cos theta upon r square dg. See, 2 again is a dimensionless constant, so you will not take any dimension formula. Sigma, surface tension, if you recall its formula, it is force per unit length, so it will have dimension formula mt minus 2. Theta, theta is the angle. Angle is not having any dimension formula, and trigonometric function cos theta is also not having dimension formula, so it will not having any formula. R is a length, radius, or this will be L, and D, density. Density is mass per unit volume, mass per unit volume. And G, acceleration due to gravity, LT minus 2. Now all the dimension formulas for sigma, R, D, G. We have substituted 2 and cos theta are constant values. So now solve this as m. M will be 1 minus 1. Here L is L minus 2. This L coming in the numerator, it is plus 3, and this is in minus 1. I am taking all the terms in the numerator. This is t minus 2 and this is t plus 2. So yes, definitely you are getting m raised to the power 0, L raised to the power 3 minus 3 0, t raised to the power 0. This is dimensionless. So what we are concluding, left hand side having dimension formula and right hand side is not having dimension formula. So the relation is dimensionally not correct. This is a point you have to take carefully, because here it may be possible the dimension formula are not identical. See, in this relation you can just do one practice. If the relation is h equal to 2 sigma cos theta by r dg. Now check correctness. You have to do this question as a homework. If you will do it, you will find that this is dimensionally correct. Do it, check it. Okay, so here initially, as I have taken 3 numericals to check the correctness of the relation, you're observing in each of the relation I am putting the value of dimension formula of each and every term and getting the correctness of the relation. One more thing before going to next numerical, I have to just tell you that as I have taken left hand side and right hand side one by one, but if you take left hand side on one side and right hand side on another side, like if you are taking left hand side on this side and right hand side on this side, never put equal to sign. Never put equal to sign, because if you will put equal to sign, it means relation is dimensionally correct. So this is contradictory. Where we are proving the relations are correct or not, we have to check whether these are correct or not. Never to start with equal to sign. Never put equal to sign here. That will be absolutely wrong. In that case, you will lose your marks. Now, after this, we are taking next numerical. Check the correctness of trigonometric relation. Trigonometric relation, you have to check the dimensional correctness. Y equal to a sine 2 pi t upon capital T, where y is displacement, t is time period. Capital T, see, capital T is different from small t. This is small t. Capital T is time period and small t is time taken, and a is amplitude. See, in this relation, y equal to a sine 2 pi t upon small t. Again, you have to check the correctness of relation. Before starting for trigonometric relation, I must tell you one thing, that whenever you have to check the correctness, first of all, any of the trigonometric functions, sine theta, cos theta or tan theta, that must be dimensionless. It means theta must be dimensionless. Why? No need to tell you again and again. Theta is an angle, angle must be dimensionless. So now, as left hand side is representing displacement, so dimension formula of y, this will be L. Simply displacement is length. Now, coming to right hand side. Now on right hand side, the term is a sine 2 pi t upon small t. Here it is capital T. Here, first of all, you will see 2 pi t upon t. Now for this term, so dimension formula is 2 pi. This is constant, capital T time, small t time. So it is 1, dimensionless. It means sine 2 pi t upon t is dimensionless. Now, up to this term, it is clear. As this is dimensionless, it means now we can check the accuracy at the next step. If this is not dimensionless, then no need to proceed further. Now, as this factor sign argument is dimensionless, now A is amplitude. So, dimension formula of A. Again length, amplitude, that is maximum value of displacement. You will study, or you have studied it in class 9th also, the term amplitude, that is maximum value of displacement. So here you are observing that Y and A both are having the same dimension formula. So you will say left hand side equal to right hand side. So see, in this statement, in this numerical, main point, first important point, you have to focus on angle. If sine of angle is, that means if angle is not dimension, if angle is not dimensionless, then equation will not be correct. So here in this statement, in this numerical, 2 pi t upon t, this is dimensionless. It means this is dimensionless, and hence when you are comparing that left hand side and right hand side having the same dimension formula. Now next numerical is check the correctness, check the dimensional correctness of the relation of trigonometric function y equal to a upon t sine t upon a, where y is displacement, a is amplitude, capital T time period, and small t is time taken. Now again, in the similar way as we have done in the previous numerical, you have to solve it. So here statement is y equal to a by t sine t upon a. So first of all, let we start for right hand side. We can also start for left hand side because right hand side is having number of terms, so we will solve it first. First of all, you will take that here sine t upon a. In it, you have to check the dimension formula of t upon a. If it is dimensionless, only then you will proceed. So dimension formula of t upon a. T is time, a is amplitude. So it is L minus 1 t. See, this is not dimensional, or this you can say this is not dimensionless. This is dimensional, this is not dimensionless. So if it is not dimensionless, it means angle, because if you will compare it, this is comparing with angle theta, as theta is not dimensionless, but this is contradictory statement. So when angle is not dimensionless, it means sine of the angle, it is also invalid. So you will say that sine t by a is also not dimensionless, and hence relation is invalid, not valid. Hence equation is incorrect. So see, in this kind of statement, you have to proceed for right hand side initially with the angle. If angle is not dimensionless, then no need to further solve a by t here or y here, because physically and dimensionally the relation is not existing. So in this way, this is dimensionally incorrect. I hope this numerical is clear to you. Trigonometric numericals, dimensional analysis or correctness of relation by trigonometric relation, it is slightly different concept, as this sine cos concept has not been studied by you till now. So what you have to simply understand, that you have to take the trigonometric function sine theta should be dimensionless, and if theta is not dimensionless, then relation is not correct. Now after this, we are taking next numerical. This will be numerical 6. Applying principle of homogeneity of dimensions. Check the accuracy of relation V equal to pi by 8 PR4 by eta L, where V is volume of liquid flowing out of capillary tube per unit time, or another way to write is, you have maybe given that V represent rate of flow of liquid. This can also be given. In both ways statement can be asked. Volume of liquid flowing per second per unit time, or V is rate of flow of liquid. Eta is coefficient of viscosity of liquid. P, pressure difference across the two ends of capillary tube. Capillary tube, any horizontal tube you can take, and the liquid when it is flowing through the tube, then the pressure difference P. R is the radius of the tube, L is the length of the tube. So within this statement, you have to check the correctness of the relation dimensionally, obviously by the use of principle of homogeneity. See, in this statement, as left hand side is representing volume of liquid flowing per second as it is given, but indirect method can be rate of flow of liquid can be there. So in the left hand side, first of all, dimension formula of V, that will be volume of liquid flowing per second, L3T minus 1. Now right hand side, in the right hand side there are many terms which we are using here: pressure, radius, coefficient of viscosity and length L. See, as first of all we will just recall dimension formula of each term. Dimension formula of P, pressure, force per unit area, ml minus 1 T minus 2. Dimension formula of eta, coefficient of viscosity, ml minus 1 T minus 1. Dimension formula of radius, this is L. Dimension formula of length, that is again L. You have to learn the formulas. If you have not learned, just see from the table and then learn it simultaneously. Now what will be the next step? In the right hand side, after this, what you will do, as here when you will substitute the values in the formula, dimension formula of pi by 8 P R4 upon eta L. See, pi by 8, this is dimensional constant. This is not dimensional from having formula, it is dimensionless constant. No contribution to dimension formula. P, pressure, M L minus 1 T minus 2. Radius L raised to the power 4. Coefficient of viscosity M L minus 1 T minus 1 and length is L. Now what you have to do, just rearrange. M raised to the power 1 minus 1. L raised to the power, here it is minus 1 and here it is plus 4. In the denominator this will be 0, minus 1 plus 1. T raised to the power minus 2 here, and it is coming this way, it is coming the numerator minus minus plus, so it is plus. So you can check M raised to the power 1 minus 1, here L raised to the power minus 1 plus 1 0, so we are taking only L for the numerator. L raised to the power minus 1, L raised to the power 4, so this one, T raised to the power minus 2 and T raised to the power minus 1, coming in the numerator it is plus 1. So what we are getting? M raised to the power 0, L raised to the power 3, T raised to the power minus 1. So dimension formula here it will be L3 T minus 1. This is identical to that of left hand side. So now you can say that left hand side and right hand side having the same dimension formula. So it means the relation is dimensionally correct. See, in all these numericals, we are simply checking the correctness of the dimensional correctness of the physical relation. We are not checking the physical correctness of relation. This is the main point you have to understand. We are checking dimensional correctness of the relation. So I have given you 5-6 numericals of the second application. Now what you have to do, you have to solve these 3 practice questions. I have written the statement for you all. So you will get all these statements in your notes along with. So today work is practice all the questions which I have explained you, as well as do 1, 2, 3 question in your main notebook. So I hope the concepts are clear to you. Now just give it a written practice, revise the dimension formula as well, and if you have any doubt you can call me. So thank you, have a pleasant day.